Hey guys, welcome back to my channel Mahaguru Yash Architecture Classes, and right now we are preparing for our GATE 2020 Architecture exam, and for that we've started solving our previous year's question papers, and right now we are in the third part for the GATE 2013 exam. So if you've got any doubt while throughout this video, please let me know through my mail or we can discuss them in the comment box below. Moreover, I'll be linking all the notes and the question papers and the answer in the description box below. So let us start with today's video. The first question is, if the area covered of one sprinkle is 20 meters square with a maximum minimum spacing of 4.6 meter and 1.8 meter respectively, the minimum number of sprinklers required to be arranged in a regular orthogonal grid to cover the area of 15 by 20 meters. Right? Now, we have a plot of 15 by 20 meter. Okay. Now, the minimum and maximum spacing of are 4.6 and 1.8 meters. So we can divide 4.6 meters the maximum spacing. So we'll try to have minimum se bhi minimum se ka, to it would be good if we have minimum se bhi minimum sprinkler, so it would be economical. So let us divide 4.6. so something 1 2 3 4 and 5. So each of them measures 4.6. So right now we are making a 4.6 by a 4.6 grid. So because that is the maximum spacing one can have. So this is 4 point this. So everything is 4.6 meters, 4.6 meters, 4.6 meters and 4.6. So this is the extra left with the 4.6, and then vertically of 4.56 grid 1 2 3 and 4. So let us just take it as again. So this is basically a 4.6 by 4.6 grid. Okay, so you'll place your sprinkler in between. Okay, similarly this will also be in between, right? And the distance will again be 4.6, correct? Similarly in this grid you'll place this in between. This is again 4.6, and it will be also given that the area coverage of one sprinkler is 20 meters square. If we see the area of this, which is 4.6 into 4.6, which is obviously less than 20 meters square. So all these grids will have one sprinkler, and one sprinkler will also place in these places, which are the cutout places. So how many sprinklers? 1 2 3 4 5. So you have 5 in this row, you've got 5 rows and 1 2 3 4 columns. Okay, 5 rows and 4 columns. So number of sprinklers would be 5 into 4, which is 20. Okay, now if the slope of a hipped roof is 60 degree and the height of the roof is 3 meters, the span of the room in meters would be, so see, span of the room. So this is your hipped roof. Okay, it has been given that the hipped roof is at 60 degrees. So this is a 60 degrees. The height is 3 meters. Okay, so let us say that this is A. Okay, so 3 by A is equal to tan 60 degree, or A is equal to 3 by tan 60 degrees. So you will get the length of this, but the question is the span of the room, and the span is basically this long. So it is 2A. The span is equal to 2A, which is equal to 2 into 3 upon tan 60 degrees. Perfect. Yeah, let's move on to the next question. These are pretty simple questions, but you might get a bit difficult ones as well. The next is volume. So we're not talking about weight, we're talking about volume. Volume of a coarse aggregate in meter cube present in 1 meter cube of 1:1.5:3 concrete made by volume batching. So the ratio of volume of coarse aggregate would be, coarse aggregate is 3. So it is basically cement is to sand into coarse aggregate. So the proportion of coarse aggregate by volume would be 3 upon the total volume, which is 1 plus 1.5 plus 3, which is equal to 3 upon 3, 4, 5, 5.5. So this is basically the proportion of your coarse aggregate. So we have to find out the volume of coarse aggregate in 1 meter cube. So it would be 3 into 5.5 into 1, out the proportion out of 1. So the answer is 0.556 meter cube to be exact. This is how we do it. Again, the next question. So some questions are like really easy and some need a bit of, sorry for that, I just got slipped. Next question is, a tank has a internal dimensions of 3 into 5 into 4 meters, has a 200 mm thick brickwork on all the sides. The volume of the brickwork required is, so we have 354 and a 200 mm block. So this is your 3 meters, this is your 5 meters. Okay, okay, and in section if you see, it would be something like this. How to find the volume of brickwork? So in the plan, first of all, we need this area. It has been given that it is a 200 mm brick is used. So you'll have 0.2 here and 0.2 here. So this length becomes 3.4. while this length becomes 0.2 here and 0.2 here, so it becomes 5.4. So the volume of the hashed area would be 3.4 into 5.4 minus the internal rectangle, which is 3 into 5. So this would give you at one level. So now it has been given that the box has a height of 4 meters. So when you multiply this hashed area into 4, which is the height, you will get the total volume of brickwork. As simple as that. Or you can do you can also do like you take the outer volume minus the inner volume. The outer volume would be 3.5 into 3.4 into 5.4 into 4.4 minus the inner volume, which is 3 into 5 into 4. The other simpler method is this. The next question is, flux emitted from a 1 CD light source in all directions in lumens would be what? We know that 1 lumen is 1 candela sterdians. Okay, and here so what basically happens is, you have a ball is there with a certain flux coming out. So if you have this a 3D sphere and a flux is being radiated in all the sterdians. So here the sterdians is basically your 4 pi the volume of, not basically volume, but here sturdian is taken as 4 pi. The total angle in a sphere is considered as 4 pi. So your lumens would be candela into sturdian. So your candela, you have 1 CD into your a full sphere has a solid angle of 4 pi sturdians. So this will give us 12.57 lumens. So I'll repeat it again. 1 lumen is equal to 1 candela per sturdian. Okay. And a full sphere has a solid angle of 4 pi sturdians. So a light source that uniformly radiates 1 candela in our direction has a total luminous flux of 1 candela into 4 pi sturdians. Okay. Let us move on to the next question. A 50-acre of residential sector has 65% buildable area. The FAR of the buildable area is 1.5. Within the residential sectors, 60% of the units are of 100 meters square and the rest 40% are of 80 meters square. The gross residential density per hectare. Residential density per hectare. So we will solve this out properly. So it has been given that total buildable area is equal to 65% of 50 hectares, which is basically equal to 50 into 60 by 160. Sorry, this is 60%. 60 upon 100 is equal to 32.5 hectares. This is the total buildable area. Now you have got an FAR of 1.5. So your total floor area is equal to 1.5 into 32.5, which is equal to 48.75 hectares. So 48.75 hectares is equal to 487,500 meters square. So you know that 1 hectare is equal to 10,000 meters square. Now let there be D. Let there be D dwelling units. So 60% of that D is of 100 meters square. So उनका total area होगा 0.6 D into 100, which is equal to 60 D, and 40% of D is of 80 meters square. So their total area would be 0.4 D into 80, which is equal to 32 D. Now the sum of this 30D plus 32D would be equal to your total buildable area, total floor area, which is 487,500. Hence the number of dwelling. Solving this, you will get D, which is the number of, sorry, this is capital D. The total number of dwelling units would be around 5299. And now we have to find out the gross density. When we talk about gross density, only the buildable area or the residential area would be considered. Your road area, recreational area won't be considered. When you so road area and this other areas would be considered while you calculate your net density. So your gross density will be total area. So we basically have to find out the gross density, which is The gross density asked is dwellings per hectare. So you have a dwellings of, the number of dwellings is 5299 dwellings per hectare. So total hectare is 50. So the gross density is 105 dwelling per hectare. Okay, let us move on to the next question. The next question says, in the given project network diagram, the total slack for job A would be. So let us name these this as not this, make it 1, 2, 3, 4 and 5. Okay, so we'll make a table here. Activity, duration, early start, early finish, late start, late finish, slack. Okay, so for your activity A and activity B, A, B, C, D, A, B, C, D, E, F, A, B, C, D, E, F. So your A activity requires 2 days, B needs 3, C needs again 3, D needs 5, E needs 3, F needs 3 as well. Okay, now A and B would start at day 0. So their earliest starts would be 0, 0 and they'll be finished at day 2 and day 3. The activity C starts when B is completed. Okay, B gets completed on 3. So it would be finished on earlier start plus its own duration. So 3 plus 3 would be on the 6th day. Your activity D. So D and E begins when A is completed. So D and E will begin when A is completed. D and E, A got completed on 2. So D and E can start at day 2. Okay, so 5 plus 2, 7, 3 plus 2, 6. Your F will start when your E and C are done. So E gets finished on 6 and C also gets finished on 6. Your F is completed when your E and D are done. E and D, E gets completed on 6 and D gets completed on 7th day. So for F to start, both of them has to be completed, so it will start on the end on 7, start on 7th, 10th. Okay, now this is when you start from the starting. Now let us go backwards. So the late start would be 10, late finish would be 10 and late start would be 10 minus 3 is 7. Now when you move on, F is dependent on D and E. So F is dependent on D and E. So it has 7 and 7. It will finish on 7th day, but it will start on late start would be 7 minus 5, 2. 7 minus 2, 7 minus 3, 4. Now your C is dependent on when E is completed. E got completed on 4th. Sorry. 7 minus 3 is 4. 7 minus 5 is 2. Now your 7. It will be 7 minus it is 4. Okay. Now C starts when this starts. This is 4. And 4 minus 3 would be 1. Similarly, it would also be 4 be 2. Once again, let me check. So E and F starts on 7th. So your slack is basically your early start minus early finish, or latest start. This minus this or this minus this. So this minus this and this minus will be same. So 0 minus 2 or 2 minus 4 will be 2. So A has got a slack of 2 days. Next question is, the scale of a contour map is 1:10,000. The contour interval is 5 meters. Distance between two given points is 2 centimeter. And the elevation between two given points is 10 meter. The actual distance between 2 points in meters would be, so 2 centimeter would be equal, on the map would be 2 centimeter into 10,000. This is equal to 200. 1, 2, 3, 4. 3, 4 centimeters, which is equal to 2 meters. So yeah, 200 meters. Sorry. Your 100 centimeter would make 1 meter. So the answer will be 200. Now, the slope between two given points is distance. The question says the contour interval is 5 meters. Distance between two given points on the map is 2 centimeters. Just wait. The scale factor is 1:10,000. The contour interval is 5 meters. So distance so your slope is equal to your vertical distance upon horizontal distance into 100. So you have a vertical distance of 200 meter. A horizontal you have a vertical. So what is slope basically? This is your slope, h by horizontal. Your vertical distance, you have an elevation point given as 10 meters divided by your horizontal distance is 200 into 10 is equal to 5%. Next question is, a point load of 3 kilonewtons acts at the midspan of 4 meter long cantilever as shown in the given figure. The shearing force at free end is, you have to find out shear force at this point. Now, since you've got no force at this point, your shear force has to be 0. The bending moment at mid span your bending moment at midspan would be 0, because this force has been counter-enforced by the reaction forces at this point. Okay. The next question is, the cost of the new building is 10,000 and its scrap value is 50. In 50 years is 1 lakh. Using straight line method, the annual depreciation of the building in rupees would be. We know that your depreciated cost, annual depreciation is basically your cost of the building minus your scrap value upon the number of years. So your new cost of the building is 10 lakhs minus 1 lakh upon 50, which is basically equal to 18,000. The book value after 10 years would be the book value. So after 10 years later, this is the annual depreciation. So after 10 years, your depreciation is 18k into 10, which is basically 1,18,000. So the cost becomes 10 lakhs minus 1,18,000, which gives you a price of 8,20,000. The next question is, a room of size 100 meters square is illuminated by 10 lamps of 40 watts, having a luminous efficacy of 50 lumens per watt. Total flux emitted by the lamps in lumens would be, so you've got 10 lamps into 10 lamps of 40 watt, and your luminous efficacy is 50 lumens per watt. So this is the total lumens would be your total number of lamps into their luminous efficacy. So this came out to be 20,000 lumens. Now if the utilization factor is 0.5 at a working height of 90 cm above the floor level, the illumination in lux would be. Now since you have a utilization factor of 0.5, the total lumens would be 20,000 into 0.5. So you'll have only 10,000 lumens available. Okay. Then your illumination would be total lumens upon floor area. The total lumens is 10,000. A total floor area of 100 meters square. So you have total lumens of 1,000 only. So guys, this is it for today's video. We'll be back with this. We've completed our 2013 question paper, and we'll be again moving towards GATE 2012 question papers. So if you've got any doubt, please write up to my email, or we can discuss in the comment section down below. I'll be linking down everything in the description box below. So please do like, comment and share my channel, and we'll be back. Thank you for watching me. I'll be back with the next video. Thank you.